I just built Black Panther's Infinity War helmet with all of the purple LEDs, and I'm going to show you exactly how I made it. Hi everybody, welcome back to the channel. My name's Luke, and in this video I'm going to be showing how I made this Black Panther Infinity War helmet with the purple LEDs. I'm going to show you what files we used, what filaments and resins you have to use to achieve an effect like this, all of the paint, all of the weathering, and all the electronics, and all of the code absolutely for free. First thing we need to do is find what files we're using so we can start building this beautiful helmet. Alright, so let's talk about the 3D files. Now, I'm getting these files from this channel sponsor, DO3D. Alright, so the main thing is this main big piece. We're going to be FDM printing that, and then all of these little detail pieces we're going to be doing in resin. And for the back, we're going to be FDM printing it, and all of its details need to be resin printed. The only thing you're not going to be printing are these eyepieces. They're a bit rubbish, and we're going to use our own and make something so much better. But the one thing you're probably thinking is, how do we do the LED effect? And that all depends on what material we use. Now, this is clear filament, but in my case, it's glow in the dark because I didn't have any clear. But basically, this is translucent, sort of clear filament, and this is what's going to make us achieve this beautiful LED effect. And the other thing is, we are going to need to be doing these pieces in resin, in clear resin. So that consists of this side piece, and these two top pieces, and the exact same on the other side. So this piece that goes there, this one, and this little orange one that you kind of can't see around the side. They are all going to need to be in clear resin. Now, I really do recommend printing these pieces all out of resin. It is very detailed, so if you do sand it wrong, if you have to FDM it, you quite possibly will lose the details. And if you lose the details, you're basically going to lose the effect, because it is going to be very crucial that we have these raised pieces to make this effect work. So try and get these to be clear resin printed, and for the face and the back, do it out of clear filament. Now, the other thing you are going to need to do while sanding is you are going to need to tape off all of these bits where the detail pieces go. It's all great that DO3D has taken these detail pieces off so we can resin print them and then print the main face, sand it, and then glue them on. But in order for this effect to work with letting our light pass through our clear filament, you are going to need to tape off every little detailed piece. You probably don't have to do all of them, but as you can see in my video, it is all one, because stupid me thought the LEDs went through everything, but they don't. So what you're going to need to do is take some really cheap rubbish masking tape and tape off all of these little detail pieces wherever there is meant to be a detail panel. That way we can allow our light through after we've painted the thing. Or otherwise, if we don't tape them, it's just going to be a build-up of paint, and we're going to have to sand the whole thing back. So it's just easier to add the masking tape at the very start. Other from that, all of our little detail pieces will resin print, do a nice wet sand, prime them. Try and not paint on the back side, just so you don't get any primer on it. So that's pretty much it over the overview of the files. Just make sure you're printing the main bodies and everything, trying to do it in clear sort of resin or filament, depending what you have available. And that's how we're going to sell the effect. Now, if you are interested in getting these files, any Doctor Doom, Ant-Man, Star Wars, you cannot look past DO3D. DO3D has an incredible range of 3D models, all commercially available, and it is crazy how many files they have. There's constantly always something coming out. Stranger Things, new Iron Man from Rivals. It's ridiculous. I can't even keep up. But if you are after getting these Black Panther files, make sure to use code CRE8 at checkout, and that way you can score yourself 20% off doing this build, because I 1000% guarantee that this is probably the best helmet that I've made. It's definitely one of the coolest helmets I've made. But if you do also stay very tuned and aware, DO3D will probably be having some Boxing Day sales, so you could probably get 50% off with using my code as well. So maybe do some more after Christmas shopping during those sales. But thank you again to DO3D for sending these files out. It was an absolute awesome build and amazing files. So the first thing that we need to go and do is start to sand this thing, and then we're going to talk about the paint. Alright, so let's talk about how we painted the helmet. Now, the first thing is, when you sand the clear filament, you'd have to be really clever in the way you do it, because when you sand it, if it's a grey or a black, it'll discolor and you can see it where you've sanded. Clear resin cannot see where you've sanded at all. So the first pass with your electric sander, you're kind of going to need to do your best to sort of remember and sort of do your best to see where you've already sanded. but then once you add your coat of primer, then you'll be able to see the layer lines, and then you go from there as per usual. But it's just a little bit funny having it clear. So once the whole thing has been prepped, sanded, and wet sanded, ready for paint, the first thing, making sure that all of these little detail sections have already been masked off with just some really cheap masking tape, so we obviously don't get our paint onto there. The first thing we're going to do is hit the whole helmet in a MS 2K black. So this is the Gloss Black by Concept Paints, and well, the main reason I've gone to this over my Elasa 2K Gloss Black is that we had some slight issues at the start. I laid down my Elasa Gloss Black, which if you've ever seen this channel before, I use it all the time. It's a 4:1 ratio, and I sprayed the thing and it looked absolutely perfect and even until I added the light. As you can see in this photo, I had the LED starting to pierce through the paint because it was too thin. It hadn't built up enough, so it looked absolutely awful. So I had to repaint the whole thing. So I did a little bit more digging and found this, which is the MS 2K Black by Concept Paints. It's a 2:1 ratio, meaning I can build the layers up. So you will also notice in some of the footage that it's already black and I've painted over it. That is why I'm applying this. So I recommend finding a paint that is going to be layerable rather than a 4:1, which really isn't layerable. Or just make sure there's enough coats of paint on so that when the LEDs shine through, that you don't have the light shining through the bits you don't want. So once that whole thing is down, and we are spraying over all of our little detail pieces, try and not get too much paint on the underside because then you're gonna have to do more sanding, but don't worry about any of the effect details yet. Just paint these as you normally would. The next thing I'm gonna do is we're going to take some masking tape and we're gonna tape off all the bits that are Illumoluster because we need to make this flat black. And the way we're gonna achieve this is by using this, which is Tamiya's TS80. This is my absolute favorite flat clear. It comes in a rattle can. It's crazy easy to apply. You only really need one, maybe even two coats. I think I did two on this just to be safe, but you layer this to any other rattle can, really nice, smooth, even coats. So you've gone from a 2K shiny gloss black to a flat gloss black. So once you've done that over the entire helmet, give this some time to dry, and then we're gonna remove the tape. Your Illumoluster bit is gonna be gloss black, and then we tape off around the Illumoluster so we can airbrush on our Illumoluster. Now the reason I'm airbrushing this on is because I don't want to be taping the entire helmet. I'm too lazy for that. And I also know that I'm going to get enough detail and control in using my airbrush because I've got enough experience from that. So we're just going to do nice even coats, building up the Illumoluster over time until it is perfect. Once we're happy with it, I'm gonna let it sit for maybe a day. I'm gonna give it a dust off with a microfiber cloth, and then I'm gonna go and hit the Illumoluster with this, which is an SMS Super Gloss. So it's just basically a super high glossy clear coat that goes through an airbrush. That way we don't have to tape the whole thing to just spray like a 2K clear over it. This super clear does an absolute perfect job. It protects and seals the Illumoluster and you cannot rub it off at all. So it is absolutely perfect for our Illumoluster. And that is the entire helmet done. Now you don't have to clear coat these little detailed pieces because this is a 2K gloss black. It's already very protected. If you want to go and add another clear coat over the top, go for it, but there's no need to. The next thing we need to do now that the entire helmet has been painted is remove all of the masking tape where our detail pieces are. And then you should get some spots where there's absolutely no paint and we can start gluing in our detail pieces. But before we start gluing our detail pieces, we need to do a little bit of wet sanding to sell our effect. Now, if you notice up on top of the helmet, if you look really closely, you'll start to see that there's a little bit of discoloration just on the top of all our details. Now, remember at the start when I mentioned about needing to resin print these and not lose those detail marks or we lose the effect? This is why. So all of those raised surfaces, take some 600 grit wet sandpaper and sand over the top of these. What that's gonna do is peel off just very slightly the top layer of paint on our raised surfaces. Don't try and dig down into the crevices because that's when you're gonna start losing the effect. Just some really nice light passes of wet sanding just over the top of all the details, just removing that tiny bit of paint. If there is little bits of paint that are not fully off, just go back really slowly and wet sand it off. Definitely wet sand it, you'll get a lot more control and a lot more time. It's gonna take longer, but it's gonna result in better ending. And then once that's done, glue everything on, and and then we'll move on to adding all the electronics on the inside, which I've still got to do some cable management for. So now that that's done, let's weather this thing, and then we're going to add all our LEDs right at the end. All right, so let's talk about our weathering, which is the easiest thing of this whole entire project. It consists of 3 different paints and a singular paintbrush. Now, this helmet, I'm going for that vibe of being on Wakanda, where we've got a combo of dirt and water and sort of that splash sort of dirt mess flick. And seeing that this is black, we can't really go with like a traditional black and burnt umber sort of texture, because it's just gonna basically blend in with our black and be completely useless. So that's why we've got to add a little bit of white to make this sort of more of a gray burnt umber. For all of these paints, I'm using the Createx Illustrator range. It is my favorite range by far. It's really, really versatile. The paints are perfectly pigmented. You can add these into an airbrush, you can water them down, you can thin them out, you can use them with paintbrushes, whatever. But if you are after some airbrushing paints or just some weathering paints in general, I 100% recommend the Createx Illustrator range. Now, the first thing we're going to need is some white. So for our mixture, the white is going to be probably the most important. That's how we're going to get this sort of finish on it. We're going to be using some burnt umber and a little bit of black. Now, I recommend taking just a little paint spallet thing. This is my first attempt. It was really dark, and then I added a little bit more white, and as you can see, it starts to turn to that sort of browny dirt, discolored desert sort of vibe. And what we're going to do is mix these all up. I do also just have like a chock of wood. You can also use some cardboard, but basically we are using this. This is my favorite brush, and if you've seen me make stuff before, you know exactly what this is. This is my stencil brush. It is the best. It is the absolute best weathering brush ever. It's relatively bristled, hard bristled, and it allows me to dab it on, swash it around, and it allows me to use it wet or dry brush it on. It's incredibly versatile. You can pull it back and flick and give that sort of splattered effect, or if you see me use it in my airbrush, which isn't actually what I did on this. I didn't really want to load up my entire airbrush just for the splatter look, but if you know what I mean, bending the hose, spraying out air, I talk about it in a lot of other videos, so watch some of them, you'll know what I mean. But take this paintbrush, take your paints, mix it up to something you're happy with, something that's not overly black, but sort of will blend in really nicely. Just do a bunch of this to try and get the paint off, so it's basically what we call a dry brush. And then we're just gonna attack the thing. Try attack a lot of your ear edges, so they look like scuff marks. Get in around the deep crevices. I did them especially around that breathing mask ventilation bit, and then just really have fun with it. The great thing with acrylic paints is we can get a bit of water and just pull it off instantly. So with that out of the way, let's now go install all of our LEDs and finish up on our code, and that will be the build pretty much done. Okay, so it's electronics time. Now, I'm not gonna go too crazy, but I'm gonna teach you exactly how to do it without trying to overcomplicate it. But the things you're basically gonna need is a USB cable. Make sure it's trying to make it one of the 2 pins. You can pick them up on Amazon, but that's what we're going to be using, is a USB pack to power the whole thing. You're gonna need some 3-pin JST connectors. This way we can also just disconnect our Wemos, which is the board we're gonna be using. So we can disconnect it like so. I'm not really too sure why I made this decision, but it's been pretty helpful just having it in there. I can remove this, plug it into my computer, while still having all of our LEDs within the faceplate. And then for the main brains of this thing, we are going to be using a Wemos D1 Mini. So it's basically like a little Wi-Fi board, very similar to an Arduino, but with a little less capabilities. But it does have the capability of Wi-Fi, and it's basically the exact same strength. So I've started using these over Arduinos, and they are relatively easy to code. All right, so for the LEDs, we are going to be using these. These are just digital RGB LED strips. These are WS2812s. So you'll either be getting the 2812 or the 2812B. They're pretty much the same, but there is slight difference of code. Try and get the 2812s just because that's what I've set my code to and I'm going to be using in this build. But if you know how to sort of change it from the 12 and the 12B, go with whatever one you want. Now I got 128 LEDs, which is 2 meters. I did have a lot of excess in the end. If that gives any indication at all. But essentially, this is the schematic. You've got the WEMOS in the middle powering absolutely everything. And then on either side of them, you've got your JST connectors. This is what's directly plugging into the WEMOS. So you've got the grounds into the ground. You've got the 5 volts into the 5 volt. And then you've also got the signal, one side going into pin 5 and the other going into pin 6. And then for the USB, you also are going to be plugging that into the ground and the 5 volt. Don't try and power the WEMOS by the USB port. Big no-no. So then you've got the first set of LEDs. This is what is going to be powering from this side all the way up. And then we're also, as you can see, there's a bend here. So that's where we're going to disconnect the LEDs at the connection points and go up to here. And then we're going to need to do another strip and go from here to down the end, and also another strip going from here to the other end. And then it's the exact same on the other side. Now, the thing you will notice is the direction of the arrows, as you can see on here. The arrows are incredibly important. If you don't have the arrows in the right spot, if they're going to the direction of your WEMOS or your Arduino, that's just sending the information back into the WEMOS, and the LEDs are not going to work. So you need to make sure that the arrows on your LED strips are pointing away from your main board. That way, all the LEDs work and you won't have any problems. I'm speaking from experience. But essentially, we are just going to be taking some just offcuts of wire. So for me, I just have this little bag of wires from JST connectors where I've cut them and this, that, and the other. But try and maybe use some 18 to 22 gauge wire. Either of them are really nice and easy to use. I believe these are 18. And that way I've got a lot of flexibility. They're really easy to strip. You can strip them incredibly easy with just a pair of these, which are just little, I believe diorama snips. They're used in that sort of model buildings things, or if you get a Creality printer, they come with them as well with the blue handles. Everyone pretty much has a set, but they're really easy. Just tie them really nicely. We're going to take our soldering iron and just slowly wire up each one, making sure ground goes to ground, 5 volt goes to 5 volt, and your signal goes to signal. And try and not overlap things and try and confuse yourself, so do really take your time. As for installing the LEDs in the faceplate, this is what mine looks like. I'll have a detailed photo here for you. But basically, just start from one end and hot glue the strip and then glue it on. I do also recommend doing the tests of the LEDs first, just so you actually know and understand them. But they're relatively easy to wire up. It's nothing fancy or overcomplicated, but we need to talk about the code because that's the thing that's actually making our LEDs work. All right, so let's talk about the code. Now for this, I'm giving you the code totally free. It doesn't matter. It's down in the description in a GitHub link. Take that, download it, and we're gonna run through it because it's really simple. All right, so the first thing is we've got the left side and our right side. Now I've done this so that you've got your right side and the left side. So the right side goes into pin 5 and the left side goes into pin 6. Now it doesn't matter, they are the exact same series and sequence of code. Just to know and not confuse yourself, put them on the left and the right. And that's put into pins 5 and 6. Now count how many LEDs you have and give yourself a couple bit more wiggle room. So I believe I only have 48 LEDs, but I put 68 because that's how I'm making this sort of pattern work. And when I talk about our gap point, I'm talking between the gap from now to now. So now to now. The gap point is basically between the start and the finish of our LED sequence. So say we have a bunch of LEDs going now, they finish, we have 30 LED pixel gap between the start and the finish. You can change this to being 3 and you'll have really short bursts and it'll kind of simultaneously go, or you can make it even longer and have a bigger time delay between when our LEDs move. So that's going to be your main one that you sort of can tweak to make it sort of the customizability of what you like. Then our brightness is how bright the LEDs are. I've just left them at 150, and the delay is how fast these go. So I've got them set to 60, which is relatively slow, although it is in reverse. So 100 is going to be crazy slow, and number 1 is just going to be one after another, like crazy fast. So I've set it more to the slower side because I want to give you, like, I want to see these LEDs sort of sequence through. I may end up making them faster in the end, but at this stage, can't be bothered. Now we scroll down. This is basically just talking about which pins we need and our LEDs. And then this is our positions and the timing and our colors for what we're using. If you want to change the colors, this is where it's going to be, but I don't know why you'd want to because we need them set to purple anyway. So basically, this is more of just the LEDs and the color. Then that's our mileage and the speeds, and then our gaps and the positioning between each LED and the sequences of them turning off and on. If you did want to go and add some fading, because I kind of want to now that I look at this, of fading it in and out, but I don't really know. I'm happy with how it looks at the moment, but the code is pretty much self-explanatory. You don't need to mess with anything besides literally this one line of code if you wish. And that is how you code an entire Black Panther helmet like this. It is not complicated in the slightest. So when you go to upload it, you're just going to want to upload, hit the upload button. You may need to download the Adafruit NeoPixel library, and if you need to, just go into this tab, search for NeoPixel, and then download this one, Adafruit NeoPixel by Adafruit. That's going to be our main one that we need to run our software, if you haven't dealt with Adafruits and NeoPixels before. It's kind of universal, so I recommend you download it. And that is it for the code. So I've left a link down in the description to the GitHub for the code, which you can download yourself. If you have any troubles with your Wemos, I'll leave a link down in the description for making my wireless Iron Man helmet. I talk a lot about the Wemos in there, so hopefully that helps. But if you do have problems connecting it during the Wi-Fi, this, that, and the other, don't feel free to leave a comment down below, and I will get back to you, and hopefully we can fix the issue. And the other thing that I'll leave is a link down the bottom for you to look at our circuit diagram, or you can pause it on this screen and you can sort the whole electronics out, because it's really, really easy. So all we've got to do left now is add our eyes. Now, if you've ever been in the whole Iron Man world before, you will notice exactly what these are made of. These are made of these. These are LED eyes for cosplay. And as you can see, they're perfectly see-through. You can pick these up for like $2 over on AliExpress or something like that. And all I've done is just made a little paper stencil, made them in, popped them in, and that's it. They're not glued, they're just really friction fit in. I just thought that gives a really good method for it. If you want to 3D model the internals and then do a car window tint over the top, that was my other option, but I kind of like how these look. They let light through when the purple goes past in this sequence, and it sort of just makes it a little bit more vibrant. But that is it. That's all our details work done. That's our weathering done. That's the paint and the files and everything done. So let's head to the final result. And that is the helmet complete. I am super happy with how this one turned out. I didn't really know if it would work. It was more of just a theory. I had multiple different ideas on how I could make this thing work, but I'm so happy with how this turned out. This has definitely got to be a top 3 of the builds this year, and well, I've got to find a way that I can permanently keep this thing powered besides just a battery pack, because it's good. It's very good. I hope you all learned something, figured out how to make this beautiful piece, and if you do end up making one of these, please tag me over on my Instagram. I 100% want to see all of your creations of this. Leave any comments or anything on what I could do to improve this or any other ideas. I'd really like to hear them. But that is pretty much the entire build complete. But without further ado, let's head to the final result.